All right, hi everybody. My name is Damon Cortese. I'm a principal developer advocate on the EMR team at AWS, and today I want to talk to you about running Apache Spark on Kubernetes with Amazon EMR on Amazon EKS. So let's dive right in. What we'll talk about today, we'll talk a little bit about EMR, just give you a quick overview there if you're not familiar with it, a quick overview on EKS as well, and then we'll talk about how to run Apache Spark on EMR on EKS and why you might want to do that. And then we'll also do a few demos too. So I want to show how to run those jobs on EMR and EKS. I want to show you how to monitor those jobs. And then I want to show you how to customize your job performance or customize your job runtime a little bit. And then finally, at the end, we'll have a little bit of Q&A too. So let's get started. So what we're seeing, our customers are running big data and analytics workloads on Kubernetes. And so what's happening is we're seeing folks want to move their analytical workloads into Kubernetes. There's definitely a move towards Kubernetes as folks are trying to consolidate resources and move a lot more of their environments and their services to Kubernetes. And what we're seeing is those big data workloads want to be moved there as well. When I was a big data architect a couple of years ago, one of the most common questions that folks asked was, hey, can we move our Hadoop workloads into containers, or can we move our Spark workloads into containers? And part of this was because Hadoop 3.0 was promising container support, and so that was on people's minds. But the other reason is there's a lot of flexibility when it comes to running your workloads on Kubernetes. It's highly scalable, for one, so you can pull together a pool of resources and you can distribute those resources a lot easier than if you have to provision different instances here and there. And you can kind of slice those off as you want. So you can get better resource utilization by doing that instead of saying, well, I'm going to have a pool of servers over here, and this team has that pool of servers, and they may or may not use it throughout the day or even on the weekend. With Kubernetes, you have a bit of a better view in terms of what resources folks are using. And so with Kubernetes, you can have a better resource utilization in order to drop costs or make the most use of your hardware possible. And then from the big data workloads too, what we're seeing there is those workloads are becoming increasingly diverse. So it's not just your finance person that's running a SQL query over some BI data. It might be a data scientist that's running a 3-hour training job. It might be an engineer that's doing some investigation or some other analysis. It might be a data engineer that's just doing some data transformation or some data cleanup. But there's all sorts of different workloads now, and so it's tough to kind of right size underlying resources to make sure that they can fit all those different workloads. And they're accessed by many different teams too. Like I said, you might have a data scientist in there, you might have your marketing team in there. There's a lot of different folks that can access that now. And then finally, Kubernetes has a fantastic open source community as well. I just saw today that the Kubernetes repository on GitHub hit 75,000 stars and 100,000 issues. And so the community is growing really, really fast. And not only is the community dedicated to making the product really great, but they're dedicated to making the community very open and very welcome as well. And that is just driving a lot of adoption there. And that's not to be discounted in terms of why folks want to move to Kubernetes. So all of that said, managing and maintaining open source workloads is challenging, right? So I've only returned to the EMR team a few months ago, and I wasn't really familiar with EMR and EKS, so I sat down, read some of the docs, wrote a command line, hit enter, and I ran my first job within a matter of minutes. I was like, okay, cool. And then I wanted to figure out, well, what would it take to run open source Apache Spark on Kubernetes? And I found a few blog posts and started diving in, started building some Docker images, started uploading those to container repositories. And within, minutes, I was stuck in how to provision all of these Docker container images and all this kind of stuff and how to deploy those and how to store those and all that. And it was just a different set of concerns. And so that's just getting started with maintaining these workloads on Kubernetes. There's other things to think about too. Once you've done kind of all that work, there's job submission, right? Do you give folks direct access to the Kubernetes cluster? Do you provide a middle layer, an API or something where they could submit jobs? And so, figuring that out is another set of concerns. And then along with that too, there's the Spark UI. So typically the Spark UI will run on the driver while that job is running. Well, those drivers are ephemeral usually, right? And so that Spark UI will only be accessible during the time of that driver. You need to figure out how to give somebody access to that specific pod in the Kubernetes cluster so they can actually access the UI. And then if you want to view that afterwards, then you have to go and start up a Spark history server somewhere, store those logs somewhere. And so even just 3 steps in to get to the point where you can run jobs, you have to worry about how to build those containers, how to store those logs, where to store those logs, how to get load balancers, how to provide access, and all this kind of stuff. And so in some organizations that might be something where you're already familiar with doing that, but in other organizations that might not be, right? You might just want to have a data scientist be able to go in and run a job and not have to worry about building a Spark 2 for Docker container, right? So that hasn't even gotten to performance optimization or auto scaling considerations that you have to think about. And so those are other things that you have to kind of to think about as well. And then finally, security and patch management, right? I also just saw recently that so far in Q1 of 2021, there's been 16 zero-day security issues in different pieces of software and hardware. So this is something that is really, really important. If you have a 24/7 security monitoring team that can take action on these things, then great. But if you don't, that's not really something you want to have to concern yourself with. And there's a lot more vulnerabilities that seem to be coming out just this year alone. If you compare Q1 of this year, where we had 16 0 days, to all of last year, I think we had 24 all of last year. And so already this year, we've almost hit most of what we've seen last year, and we're not even done with Q1. So a lot of different reasons that you might not want to manage and maintain your own open source workloads on Kubernetes. So what we've done is we've got a new deployment model for Amazon EMR that makes it easier for you to run Spark on Kubernetes. And so what you can do is you can now run EMR on EKS, and you may have your data science pipelines and notebooks up top there. They can still interface with EMR. And typically you were deploying EMR on EC2 instances. So that's the existing deployment modes. And so you could have existing EC2 as well as AWS Outposts is where EMR was supported. And now we've added EKS. And so we've made it really, really simple to run Spark on Kubernetes. This is something that is really important here. It's a new deployment model, and that's something that I want to focus on. And let's talk about the differences of what that actually looks like. So first, if you are running EMR on EC2, it's more of a cluster-centric model, right? So you run a single version of Spark per cluster. You have a shared execution role, which means every single job that runs on that cluster shares the same set of permissions. And what happens is, if you see on the right-hand side there, this is the stack of infrastructure that gets provisioned, right? So EMR takes the EC2 instances, provisions those, manages those with whatever OS you've chosen on those. Above that, there's Yarn. That's the resource scheduler for the different applications running on that cluster. There's Spark, and then the EMR specific components on top of Spark, and then finally your application and dependencies. And so EMR manages that whole stack over on the right-hand side, which also means you have to think a lot more about, well, what type of EC2 instances are you going to deploy? How utilized are those EC2 instances? What are we paying for those? And a lot of other things like that. This model, this cluster-centric model, it is great for jobs with cluster-scoped dependencies, and it's great for clusters running at high utilization. So if you know you have a Spark job that's going to run for 3 hours straight, and you run it every single week or something like that, it's really great to be able to spin up this entire cluster, dedicate the entire resources to that Spark job, and spin it back down. But the world that we live in is a little bit different, right? And so with EMR on EKS, containerization is driving this job-centric model. So instead of a cluster-centric model, what we have now is everything is kind of more scoped to the job. And if we look at the infrastructure again on the right-hand side, we kind of split it in half. So EKS now manages the operating system and the underlying EC2 instances or Fargate pods if you're going serverless. And then on top of that, EMR builds and runs the Spark runtime as containers. So EMR takes care of hosting those container images and deploying those. And on top of that is the EMR specific components, and then finally your application and dependencies. So this allows for a lot more flexibility, right? On a per job basis, you can run different versions of Spark. On a per job basis, you can also have different execution roles. So your jobs can have different permissions for each and every separate job. So that makes it really, really useful to be able to kind of separate concerns really, really easily. The other thing this is great for is quick test and upgrade cycles. And so by changing just the EMR version number, you can switch from Spark 2.4 to Spark 3.0. And that's, literally a two-character change, and I think a one-character deletion too. So it makes it really easy to test your upgrades and see if that works. And it's also great for consolidating resource utilization. So Kubernetes has capacity to auto scale and all that kind of stuff, and you can kind of manage and share your resources a little bit better. So what does this actually look like when you're running Spark on EKS clusters with EMR? So the first step is registering the EKS cluster with EMR. EMR creates a virtual cluster that essentially points to the EKS cluster that it will use for running those jobs. This helps to consolidate infrastructure across your organization. You can have multiple virtual clusters per team or per part of your organization that points to the same EKS cluster. So you can manage your resource limits by teams or workload or however you want to split that up. You can also start jobs really quickly, right? That capacity is already there in EKS. Those jobs start in seconds. If you're familiar with EMR on EC2, you still have to, create new EC2 instances when you're spinning your cluster up in the first time, and that can take minutes, but sometimes even minutes might be too long, especially if you're doing really interactive workloads. One of the other benefits of EKS is by design, it can be run across multiple availability zones. And so you can run your Spark jobs as well across multiple availability zones. Or if you want to, you can scope those down to a single AZ as well. Where that's helpful is if there's a lot of data transfer between your jobs, you can limit the job to only run on that single availability zone. Finally, you can also choose serverless with Fargate on EKS. So the diagram on the bottom left-hand side there, that shows a typical EKS cluster. It's spread across multiple availability zones, and each availability zone can be comprised of EC2 node groups or Fargate serverless. So what happens there is you can run EC2 and Fargate together. You have your applications on top of that, so you can run, your web apps on EKS or whatever other applications you want to there. And then you can have multiple different versions of Spark and multiple different versions of your analytics. So it allows for a lot more flexibility just in terms of deploying new types of work to that cluster. So EMR helps accelerate that move to EKS. We do that by providing a managed distribution of Spark on Kubernetes. So we have Spark 2.4 and Spark 3.0. The corresponding EMR version is EMR, I believe it's 5.32 and EMR 6.2. And so you can deploy either of those to your EKS cluster. We manage the job execution on your behalf. So we take care of deploying the job to the cluster, monitoring the job, reporting back the status, and we also simplify secure execution. Like I said, each job can have its own execution rule. There is, of course, native integration with S3 and the Glue Data Catalog and the different AWS Analytics services. One cool thing that I'll show later too is we simplify debugging with the Spark History server. So each job you can kind of log in and look at the Spark History server either while the job is running or even after it's terminated. And then from a workflow perspective, there is integration with Apache Airflow as well. So there is an EMR and EKS operator, so you can trigger workflows from your Airflow. Finally, there's a differentiated performance runtime with EMR on Apache Spark. So we've taken Apache Spark and we've done a lot of work, especially over the course of the past year, to make Spark run better and better on EMR, whether that's on EC2 or EKS. So a pretty chart for you. If we take the Spark performance with the EMR runtime, we took open source Spark and compared that to the EMR Spark runtime, and we just used the standard TPC DS benchmark. So with open source Spark, that took 92 seconds to run, and with the EMR Spark runtime, that took about 47 seconds. So with the Spark runtime on EMR, we can have greater performance just by running that Spark runtime versus open source Spark. So with open source Spark, if we run the TPC-DS benchmark, that completes in 92 seconds. On the EMR Spark runtime, that completes in 47 seconds. So this is just a benchmark, of course, but we use these benchmarks to kind of determine what types of performance improvements we can make, and so that gets us a 2x performance improvement just by running the EMR Spark runtime. So not only will your jobs run faster, but they will also run at a less cost, right? Because you don't need as much time to run those jobs. So just by switching on the EMR Spark runtime, you can get some automatic job performance. So that's pretty nice there too. So I want to walk through what an example architecture of this looks like. So what we've got here, we've got EKS on the right-hand side, and we've got EMR over there. One thing I want to call out is it is very important to talk to your EKS operator. So probably if you're running EKS, somebody in your organization is responsible for managing EKS or operating it, and you want to be able to talk to them first before just kind of running your Spark workloads on it, because they will need to understand the different types of capacity that you're going to need. And we'll talk about that a little bit later on, but they'll need to understand, how much memory you're going to be using, how much CPU you're going to be using, so they can properly kind of make sure that they have the right resources in that cluster. So the EKS operator is going to go ahead and provision different namespaces on EKS, and in this case we have EMR on EKS1 and EMR on EKS2, and then we'll register those namespaces with EMR. So now you have virtual clusters on EMR that are pointing to those different namespaces. Then we might have data engineer one. This is a person that can use that first namespace. So they'll submit jobs on EMR on EKS1, and they can use whatever release they want to. What happens is EMR creates the Spark pods based on that configuration. And so those pods get created. EMR creates a job runner that goes and deploys onto the EKS cluster. That job runner goes ahead and starts the necessary driver with the necessary Spark runtime. And then the tasks also get started from that driver, and that can go across both of those availability zones as well. So that is one person coming in, running a job. And then we have a second data engineer. They come in and they will submit a job in that second namespace. And that can go to the same EMR cluster, and that will go ahead and provision a second set of Spark runtimes on the cluster in a different namespace. And so again, that job submitter pod gets deployed to EKS, that starts up the drivers and the tasks, and those go ahead and run on the EKS cluster. So there's a few different job submission options there. One, you can just submit jobs via the command line interface. Two, you can, of course, use the SDK to submit jobs that way. As I mentioned, there is an EMR on EKS operator for Apache Airflow, so you can use that as well. And then step function support is coming soon too. When it comes to job debugging options, again, a few options there. So you can, of course, send your logs to CloudWatch and log those there, or whatever interface you have to CloudWatch. You can send logs to Amazon S3 as well. Inside the management console in EMR, you also have access to the Spark history server. So if you're familiar with that interface, you'll be able to go in and debug jobs that way too. And then EMR Studio, which is currently in preview, you can use that to connect to your EMR on EKS clusters as well and debug jobs that way. So a lot of different options to go in there and kind of work through your jobs. All right, so I'm going to pause now, and I want to do a few demos, like I talked about different things you can do on EMR and EKS. I'll start first with job creation and the app UI. What I'll do is I'll switch over to my demos over here. And so what we'll do, the first thing that we want to do, I just want to show how to create a simple job using a built-in PySpark script. Before I get started, let's take a look at what the virtual clusters interface looks like on EMR. So if you've used EMR and EC2 before, you're familiar with this interface over here. You've got your clusters, your notebooks, other configuration items. Down here, you've got your EMR and EKS section, which has your virtual clusters. And I have two virtual clusters running. They have two different namespaces, and they're connected to the same EKS cluster. If I go over to the EKS cluster, we can see here I've got both Fargate and C5XL nodes provisioned. If I go into the workloads here, I can see different namespaces that I have set up coming over. And then my configuration just shows standard EKS configuration there. You may or may not have access to this interface, but I'll use it throughout the demos to kind of show you what's going on. And then there's also the Kubernetes dashboard. This is installed on the Kubernetes cluster itself. And again, this is usually used by Kubernetes operators. And you may not have access to this, but it's really helpful to show what's going on under the hood. So I'll make use of this too. So that's the EMR console, pretty straightforward. I've got my virtual EMR cluster here that I'll be submitting jobs to. And you can see I've already run a few jobs here. And if I close the sidebar, you can see all the different logs for some of those jobs as well. So let's go ahead, submit a simple job and see what happens. So what I'll be using the EMR containers subcommand for the AWS command line interface, and I'll be doing a start job run. A few things to call out here. You specify your virtual cluster ID. So this is the EMR virtual cluster, the name of your job. The execution role, like I said, every job has an execution role associated with it. So this is the permissions that your job might need, whether that's to write to S3 or gain access to other different services in AWS. That's a per job role. You specify what version of EMR you want to run. I'm going to use 6.2 because I'm running on Spark 3. And then finally, the important stuff, the job driver. So this is where you configure how you want to submit your Spark job. For the purposes of this demo, I'm just using a local PySpark script that estimates the value of pi. That's a sample script that comes on every version of Spark, and that's just located locally on the container that we provisioned for the Spark job. If you want to, you can change this to S3 to point to script code on S3 or what have you. And then finally, the Spark submit parameters. This is fairly standard. You specify that your number of executor instances, executor memory, cores, all that kind of fun stuff. So let's go ahead, copy this, and see what happens. And so this is going to the EMR API, submitting the job, and you get back a job ID as well as your virtual cluster ID. So if I switch over to back to the console and refresh the console, I should see my sample Pi job right here is submitted, and it's still getting started. If I go over to my Kubernetes dashboard, what I'll see is I've got my job submitter that is created right here. So this is the job submitter that goes ahead and creates the drivers, and you can see the job is already starting to spin up. So the job driver started right here, and that's already going ahead and running. And we've got some executors that are starting to spin up here. Now, my cluster has the Kubernetes, the cluster autoscaler enabled on it, and I don't have a lot of capacity kind of spun up right now. So I might not have that job run right away. And this is something, again, where it's really good to talk to your EKS operator so you can say, hey, we expect to be running jobs, during working hours or what have you, so that the proper capacity can be provisioned. And what that looks like is now my two executors that started up here are kind of stuck in this pending state just because they're waiting for more capacity. But this is where Kubernetes is really awesome. The cluster autoscaler is there, it's running. It will detect in probably 30 to 60 seconds that I need more capacity. If I click on this, you can actually see that error. I don't have enough pods, I have insufficient CPU. And so that cluster autoscaler will detect that, and it'll go ahead and spin up new nodes on that cluster, and then the job will start running. So let me go back here. I'll do a quick refresh, and you can already see we're spinning up two new C5 XL nodes there. And so those are spinning up, provisioning. They spin up pretty quickly. And what we should see pretty quickly here in the Kubernetes dashboard is we should see that job start to run. Now, what I'm also going to do, I'll flip back to the EMR console here, and I'll click on this View Logs button. So like I mentioned, once the job gets submitted to the cluster and it starts running on the driver, you'll have access to the Spark history server, both for existing jobs as well as completed jobs. So I could go down to any of these other previous jobs down here and say, okay, show me the Spark history server for that as well. And if I go back to the Kubernetes dashboard, we can see that for this first Python executor, that's already going ahead and executing. That container is creating, it's going to start running right there. If I go to the Spark history server, the application will still be incomplete. And when I dive into that, this is the standard Spark history server interface that you're used to. And so you can kind of click around in here and you can see, okay, wait for that job to pop up. Those jobs are running now. This is going to be a pretty quick job because it's just estimating that value of pi. But we can see there's my Spark job right there. So I can click into that. I can download the event log from it, and you can kind of see what's going in like you normally would on a typical Spark job. So I can see my event timeline. I can go over to the executors tab, and I can see what different executors are running and all that kind of fun stuff. So there's one of my executors. It's already processed, two tasks, and I think that's probably spinning down already because it ran so quickly. Yep, it did. So back in the Spark history server, one thing to note, there's a little info message here about downloading standard out and standard error logs. If you're used to the Spark history server, you may use it to download the logs from your executor. If you do want to do that with EMR and EKS, you need to enable S3 logging so it has somewhere to store those logs for you to download. So that's what we'll do next. Let's go back to the EMR console really quickly and refresh. And now we can see that sample Pi job is completed. It took a little bit longer than I wanted because my cluster didn't have the capacity. But the good news is the cluster autoscaler responded, spun up that capacity. And if I don't use this capacity in a few minutes, it'll spin it back down. So let's move on with the next part of the demo where I show how to enable CloudWatch and S3 logs. For this demo, I want to show you how to enable S3 and CloudWatch logs for your EMR on EKS jobs. So let me go back to my little demo over here. We'll scroll down to that section. So what we want to do, I showed you the Spark history server, and that's one way you can monitor your Spark jobs on EMR on EKS, but we can also log to S3 or CloudWatch. So what we'll be doing, we'll be adding a new parameter to that EMR containers start job run command. We're going to be using this configuration overrides section. So let's look how to do that for CloudWatch. One prerequisite, you have to make sure your desired CloudWatch log group is already created. So if you don't have access to create log groups, make sure you have somebody create that for you ahead of time. And then make sure that the role you're using to run the job has the right permissions to write to the log stream. So what we'll do, we'll run the same job as before. This command here is exactly the same as before. We're submitting to our EMR EKS virtual cluster. We are using EMR 6.2 with that Pi job. We're going to add this configuration override section here. So inside there, there's a monitoring configuration, and then finally a CloudWatch monitoring configuration. So this is where you specify the log group name that you already created, and then a log stream prefix. So let me go ahead, copy that, run it down here in our terminal. And again, this submits the job to the EMR API. If I go back to the EMR interface, we should see that that job, Decort Pi CloudWatch, is now submitted. If I go back to the Kubernetes dashboard, here's the job submitter again. That's spinning up. It's going to create the Spark driver. And that is now spinning up, and the Spark driver is going to create all the Spark tasks. So let's go back, and what we want to do is we want to look up our CloudWatch console. So let me open that really quickly. And so in the CloudWatch console, I've got a bunch of other previous streams in here, but we can see, I'm pretty sure this is the driver that just spun up. So we can see the Spark driver standard error. And these are, fairly standard text or fairly standard log messages from Spark. You can see, the context handler spinning up. You can see the cluster scheduler spinning up there. So you have all this information about the job that is normally accessible to you in standard error and standard out. You can, of course, view as text. That gives you a little bit of a better view to be able to see the whole line in there in CloudWatch there. And if we go back to the CloudWatch console, what we can see, I'll do a quick refresh, and what we can see is we've got our driver standard error, our driver standard out, and then for each executor that's created, we also create log streams for standard out and standard error on those executors. So this could be a lot of logs, but it gives you access to what's going on anywhere in your cluster, really. So let's click on the Spark driver standard out. And in there, this will have any messages that are logged in the driver. In this driver, we are just logging the estimate of pi. So we say pi is roughly 3.13. And that's where your logs from Spark will go to. So pretty straightforward. Let's see how to do that with S3 now. So I'll go back here. S3 is pretty similar. You just have to make sure that you've created the S3 bucket. And again, the role that you're using has the ability to write to that bucket. So what we'll do is we're going to add an S3 monitoring configuration to that same monitoring configuration section that we used before. So we're going to leave in our CloudWatch monitoring configuration. So you can have both CloudWatch and S3, or you can just have one or the other. So we're just going to do S3. And what we do is there's a log URI section where we specify our bucket and prefix that we want to log this to. So again, I'll go ahead and copy that command, paste it. If we go back to our EMR cluster, we will refresh that. We'll see Decort Pi S3 is now pending. If we go back to our Kubernetes dashboard, we can see that the job submitter is running and the Spark driver will spin up pretty soon as well. So there it goes. So again, these jobs spin up in seconds. Pretty awesome to be able to have this kind of capacity right at the tip of your fingers. And I can't wait to show a little bit more about that as well. So what we'll do, let's take a look at what's inside that bucket. You can see we've got two different IDs in this bucket. What those are is for each different virtual cluster that you have, that will be stored in the bucket. So I've run some jobs here before on a different virtual cluster, and I want to dive into the logs for that one. Then there's a jobs folder, so you can look inside there, and each job will be represented in there as well. So that FLE job is the one that we want to look at. I'm just going to do a recursive listing of that to see all the files that are in there. And this will look very similar to the CloudWatch console as well. You can see we've got our Spark driver standard error output, our Spark driver standard output. And then for each executor, we've also got standard error and standard out. So this is really great because you can go in there and log all this information to S3 if you want to have this around for a while. That's really nice as well. CloudWatch may have some retention things where that'll disappear after a few days, but then you can store this in S3 as well. So let's take a look at what it takes just to look at one of the files that's in there. So I can just copy my S3. I'm going to just copy the standard out of one of those files. So let me do that really quickly. So I'll copy standard out, copy that to my console, and then we'll have to unzip it because that's a gzipped file. And again, this should just show us the standard out of the driver. And again, we get pi is roughly 3.14. So this is an estimation script. It changes every time, but that's how you could get the standard output of those scripts as well. So if I go back to my console, you may have noticed I clicked on View Logs here and popped open the Spark History server. What I wanted to do is show how those logs show up in the Spark History server as well. So let me pop that open, and again, I'll go into the Executors section. And inside the executor section, now that we enabled S3 logging, what we should see is we should see those standard out and standard error logs show up in the executor section as well. So this is really great because you as a data scientist or a data engineer, you don't necessarily need access to Kubernetes or S3 in order to go and download those logs. They're going to show up right here in the Spark History server. So just from the EMR console, you can launch the Spark History server. You can look at the runtime of your job, see what's happening, and download those logs. So pretty cool. Those are the two additional ways to monitor your jobs using S3 or CloudWatch. And then for the next thing, one thing I just wanted to call out as well. If you're looking at the output of that bucket, this is the format that you'll see. So there's the bucket and the prefix. There's a cluster ID, a jobs prefix, the job ID, and then there's also containers and Spark ID, and then you have your driver or executor and standard out or standard error. So that's the format for all the jobs, all the logs that are getting put into S3. So that is additional logging and monitoring. Now I want to talk about how to do a little bit of optimization. This is the really fun part of the demo. So for this demo, I want to show how to optimize or how to tweak and tune your jobs running on EMR on EKS. So let's switch back to our demo script here. There's a few ways of customizing how Spark jobs run on EMR and EKS. One, you can manually specify your executor cores in memory. This is no different from standard Spark where you're changing how many cores per executor you have or whatnot. Two, you can utilize dynamic resource allocation. So Spark 3.0 on Kubernetes and greater, you can utilize this to have Spark try to figure out how much resources your job needs during the runtime of the job, and it can respond within seconds. And then finally, you can do explicit instance placement with Kubernetes labels as well. So this is pretty advanced, and it would require you to work with your EKS operator to understand what resources are under the hood, but it can be really helpful if you do have specific requirements for your job. So let's walk through these a little bit. One quick assumption, a lot of what we discussed below assumes you're either using the cluster autoscaler to dynamically add resources to your EKS cluster, or you're utilizing a serverless approach with Fargate that can automatically add resources to the cluster as well. So just wanted to call that out because a lot of these are going to spin up new instances or request new capacity. So first, customizing Spark submit parameters, no different than standard Spark, but a couple things that I do want to call out. One, you do need to be aware of what instance types are in your EKS cluster. So if you request Spark executor cores equal to 10, but all the instance types in your cluster are extra large or small, and those XL instances only have 4 vCPUs or less, your Kubernetes pods will get stuck in the pending state waiting for CPU cores. And this is just because when Spark says, hey, I need an executor that has 10 cores, there won't be any instance large enough to satisfy that requirement. And Kubernetes will wait to see if some other component on the cluster responds to that, like the cluster autoscaler or manual intervention. But if nothing does, those will get stuck. So let's see what that looks like really quickly. This is the same demo job that I ran before. The only thing I'm changing is the Spark executor cores equal to 10. So I'm going to say, hey, give me 2 executor instances and make sure they have 10 cores each, but my cluster is not provisioned for this. So let's see what happens. I'll go back to my EMR console. You can see my sample pi with 10 cores is submitted. Over on the Kubernetes dashboard, you can see that The job submitter is there, and apologies for that error state. That's just unrelated to the demo. We can see that the driver is going ahead and creating there. And if we look at our EKS configuration, I'll refresh this again, and we see that we only have Fargate types in there and C5XLs. And so when I go back to the Kubernetes dashboard, we see our executors kind of stuck here, just waiting for capacity. And if I click on this little info message again, you can see again, we've got insufficient CPU. So we saw that error message earlier, and the cluster responded to it using the cluster autoscaler. But this cluster is not configured to add anything over an XL. And so it'll never be able to respond to it. And that job will just kind of be stuck there, pending, waiting for resources in the cluster. So let's go ahead and cancel that job. I'll use the EMR containers subcommand again to say cancel that job run, and I will add the ID from there. So we'll cancel that. We don't want that sitting around and waiting for resources. One other thing to call out, if you're running EKS with Fargate, you can't use a value greater than 3 for that Spark Executor cores. Again, Fargate only has a max supported configuration of 4 vCPU, and there's some additional Spark overhead there. And so you can only have 3 cores when you're running EKS on Fargate for your Spark job. So just something to be aware of there. Other than that, tweak it as necessary for your job. It's really helpful to play around with some of these values to see what happens, see how your jobs run. If you're not familiar with Spark, it's useful to kind of see how the Spark job responds. So what I'm going to do, I'm going to tweak this Spark Executor instances configuration item here and say, hey, give me 10 instances, and I want each instance to have 3 cores. Again, we're just using this Pi job here, so it's not a huge job. I am adding an argument to the Pi job to increase the number of partitions, but let's see, just kind of what this looks like. So I'll take this and I will paste that in there. And what we should see is if I flip back to the Kubernetes dashboard, what we'll see, here's our job submitter. That's going ahead and that'll create the driver. And what we should see is a bunch of executors start to try to spin up instead of just the 2 that we normally saw before, because we specified a higher number for the executor instances there. What'll also happen, oh, there we go. So we've got executor 1, 2, 3, 4, and 5. So we've already got 5 executors running. 2 that are running and a few that are pending because they need capacity there too. But we've already got 2 that are up and running and going. And so if I go back to my EMR console, just want to see those logs again when they come up. But here's our EKS cluster. We can see the capacity that we have in the cluster. What's going to happen again, I requested more capacity than is available in the cluster right now. So the cluster autoscaler will respond to that and spin up new nodes. This is a really short job, so it's already terminating. It's already spinning down. So we were able to see that if we spin up the number of executor instances, that just by default requests more resources from the cluster. So pretty cool to be able to do that. And then the other thing I want to do is I want to talk about dynamic resource allocation. So this is pretty interesting. This is a way to provide a mechanism to dynamically adjust the resources your application occupies based on the workloads. So this is neat if you don't necessarily know, what your workload is going to do, or if you have multiple stages to your workload that have different resource requirements throughout the course of the entire job run, right? So what this means is your job might start off, it might require a bunch of resources to kind of go and do some analysis. It might slim down for a little bit, might not require quite as many resources in another stage of the job. And the capacity in the cluster can kind of dynamically respond to this, which is awesome, right? This is computers trying to help people do their job better. And I personally love it when that happens. So let's take a look at what dynamic resource allocation does. One thing to also note here, typically, DRA requires an external shuffle service, which isn't supported on Spark on Kubernetes yet. And so what we can do, though, is we can enable shuffle tracking. And so that'll help allow us to run DRA on the Kubernetes cluster. So what we're going to do, we're going to add a new configuration override. We're going to override the application configuration. So this section allows us to overwrite the Spark defaults. We're going to enable the dynamic allocation. We're going to enable the shuffle tracking. And then what we're going to do is we're going to configure that dynamic allocation. So we don't know exactly how many resources this job needs, but let's say we're going to start with 5 executors. We'll let that go all the way up to 100 executors and all the way down to 2. So that's a pretty broad range, but this job may or may not require a bunch. For this sample job, I'm actually using a different script. So I have a script. It was a really windy day in Seattle a couple months ago, and so I wrote a quick PySpark script to calculate the max wind speed on each day. And so I'm going to use that script because it goes over a lot of data from the registry of open data on AWS. So, if you're from Seattle, you may recognize some of these latitude longitudes. That might be actually, I think that's all of US. I tried to bump that up. Anyway, so what I'm going to do, I'm going to copy this command, paste it in there. We'll see how that runs. So we'll go back over to my EMR cluster. You can see that my Decourt Windy City is now pending. And if we go to the Kubernetes dashboard, actually, let me pop open the logs for that as well. If we go over to the Kubernetes dashboard, we can see the driver is already spinning up, and let's see what happens with those executors. We specified 5 executors that we wanted to spin up at the beginning of the job, and pretty quickly here we should see 5 spin up. So you can see there's my Windy City executor. We've got 5 of those spun up, and now that the job is starting and running, what's going to happen is Spark is going to keep an eye on how many tasks are still pending for that job, and if there's a lot more tasks, it'll go ahead and spin up more executors. So pretty cool, where you just need to have some more compute capacity added. And if you are running something like the cluster autoscaler or with Fargate, it's really awesome to be able to have more capacity kind of just at your fingertips to be able to expand your cluster with. So let me relaunch that Spark history server there. One thing to note, if that driver hasn't kicked off yet, you might get an error in the console that just says, hey, the logs aren't available yet, but that's pretty expected. So I'll go back to the Kubernetes dashboard, and what we can see is we actually see a bunch more executors starting to spin up here. So you can see we're already up to 16 executors, I think. 10 of those are already running, and the EKS cluster is probably trying to respond here as well. So it's probably trying to get more capacity. So let me go in here. So yeah, 4 minutes ago, we spun up 3 more C5 XL nodes. The EKS cluster is going ahead and just saying, okay, cool, you need more capacity. I can give it to you. Here you go. And then in the history server, let's go and look at the incomplete applications. What we should be able to see here is the different stages of this job um, as the capacity is added. So what I'm going to do is I'll click into this history server, zoom in a little bit for you so it's not too small. And while that's loading, I'll go back to the dashboard, and you can see we're up to, let's see, 17 executors. So it's continuing to try to add more and more executors. And if I go back here, I can look at my event timeline in the Spark history server. And you can see right here, this is when the job spun up, and we immediately had 2 executors added. And that rest of that batch got added a little bit later because we had to add some more capacity. But you can see the additional executors start to come online here. Like here's 10 and 11 and 7, 8, 9. And so this is pretty neat because you can just see that additional capacity continuing to get added to the job. So from a Spark perspective, if you don't necessarily know what your workload is going to look like, or you know that your workload is going to have a variable amount of resources throughout that run, the DRA on Kubernetes can be really useful, and even more useful if you're using Fargate too, because you can just continue to request more and more Fargate resources, and you don't necessarily need to have node set up to serve that capacity. And see, we're up to 21, 22 executors here. So this just keeps going, which I love this because I love just watching the cluster respond to the resources and add more and more executors. And you can see here too, here's all the executors. You can see the tasks in this column that get executed over the executors. So you can see the early ones had 1,000 tasks. The later ones that came in didn't have quite as many tasks. So maybe next time when you run this, you say, okay, I ran this with the dynamic resource allocation. I saw that it needed 10 executors right away. So let me go ahead and request 10 right off the bat. And then you can kind of see what happens based on that. So just a lot of tweaking and tuning and all that kind of fun stuff. And I think this job might start. It's almost done. It takes a few minutes to run. Like I said, it's chewing over a bunch of weather station data to tell me which days are the windiest. And we're up to almost 30 executors here. So just really cool to see that cluster kind of auto scale, kind of give you that capacity and do it by itself without you really having to worry about it. So that's dynamic resource allocation. Pretty neat. And one of the ways that you can kind of tweak and tune your Kubernetes cluster. Thank you for joining us today. I hope you enjoyed the demos and the overview of running EMR on EKS. There is a 2021 AWS Summit coming up, so please join us for that. And thanks again, and we'll hop into a little bit of Q&A.